Hello and welcome to today's debate on bringing Industry 4.0 to the high-mix factory environment. The smart factory revolution is not limited to large volume manufacturers, and this panel will discuss the steps that small to medium-sized manufacturers can take to optimize their equipment and processes and develop an Industry 4.0 led strategy. I'm joined by a very distinguished panel, an informed panel, and to my extreme right we have Mark Ogden from ASM, Assembly Systems, and to his left we have Michael Slinsky actually, who's the General Manager of Technical Operations at Panasonic. To his left we have Ranko Vučević from Optimal Electronics, and to my immediate right we have Mitch DeCare from Kojiscan. So that's our panel today. Welcome, gentlemen. And I'll get straight in with my first question to you, which is, I'll probably direct to you, Mark. How can Tier 3 and 4 manufacturers optimize their supply chain most effectively inside the factory?
Hello, Trevor. Very good question. Looking at where we see the most optimization, I think, is in the material supply to the line, and also the reuse of material in a factory. We did some studies with a consultant earlier in the year, and we found that average EMS company is spending 3 minutes looking per component for an assembly, and they're spending an average of 7 minutes returning a partial reel back to their warehouse. Now you think about how many unique parts are on a board, 100 or 200, multiplied by 3 minutes to look for it and 7 minutes to count it back and put it back. If you can automate your material supply so that the vendor knows exactly where the parts are in a factory and how much material is still on there, you eliminate a huge amount of time and overhead savings. That's where we see the biggest lever for the high mix environment.
Yeah. It's an excellent point, and I think as far as Michael's concerned, you've got a fairly good inventory system there that you're actually demonstrating here at the show that handles materials management.
Yeah, we believe the same thing, that being able to get material to the line in the most effective way and knowing what you have in inventory is critical. And we have actually partnered with companies, and Innovax is one of them, but to provide that material handling solution to actually basically call for a kit, have it be brought to the floor in a way, and then as you go to set up, as you go to put it out, it's already telling you which reel to go into which location. And where the big data comes into this, or where Industry 4.0 comes into this, is that you need to recount these reels. It's knowing what quantities are on all the reels and knowing which specific reels to pull. Specifically, if you have the same part number on different reels, you want to pull the one that only has 500 pieces left, because that's what you're going to use on this job. You don't want to pull the one with 2,000 and create that. And having a system that, one, knows what all the inventories are in each individual reel and has each unique ID, and also is telling them which reel to pull for a job, so you're most effectively moving the inventory through your factory without having to pull something off or move it to a different line is key.
Yeah. No, I think materials management is key. Ranko, do you have a view on this?
Yes, from my experience, the biggest problems in a plant regarding materials are inaccurate counts in SAP ERP system, and running out of parts unexpectedly in the middle of the job, and also losing parts. So losing parts is more problem with the bigger, larger contract manufacturers, for example, and in a lot of time they call us and say, what kind of solution do you have to help us find our parts? Because once we take it off machine, we have no idea where it is anymore. Now, inaccurate counts on each reel affect your ability to prepare your job on time and also not run out of parts. But the biggest problem is inaccurate counts in the ERP system, because ERP system will not order parts on time and will also release a job that actually cannot be completed. So all these things can be eliminated with a with in Industry 4.0 with collecting data in real time and providing feedback to ERP system in real time, but at the same time providing mobile solutions for materials management to be able to quickly solve the problem, including tracking where the material is.
Yes, yes, no, I agree. Mitch, do you have a view on that?
Yeah, absolutely. I agree with my colleagues to my right. High-mix manufacturing, by its very nature, results in more partial reels, more partial containers of materials throughout the four walls of the factory, both in the stock room, line-side inventory, and as well on the lines. So the number one opportunity for high-mix manufacturers who want to embrace Industry 4.0 is to focus on material control. And all of these good points that were just raised by my colleagues have something in common. And in my opinion, and in Kajaskan's perspective, the foundation for implementing these ideas is to start with connectivity. In order to track the materials, in order to know how many materials are on each reel, we need to be connected to every machine that is consuming materials, whether it's a old machine, whether it's your latest machine from one of the leading vendors. And that way, by having this connectivity to the machines, we can make this inventory data available to other systems. At this trade show here in Chicago, we see a lot of vendors marketing automated storage solutions, which are a very powerful complement to this concept. If the pick and place line can be connected to a storage system, then as we're counting these components, we can actually tell the tower to prepare that reel and have it presented to the operator. As Mark pointed out, I mean, with the modern machines we have and the throughputs they have, if you don't have a handle on this, your line is going to be stopping constantly because of an empty reel situation. So here you have a beautiful SMT line, state-of-the-art technology, and a $4 reel of resistors brings you down by connecting to the line, connecting to the storage systems, as Ranko pointed out, connecting to the MRP, so that all these systems are synchronized. The customer is able to know exactly what they need and where they need it and can get it there just in time to keep their lines running and avoid downtime.
Right, right. I think they're all good replies, guys. The one point I would make is that to Ranko's point of losing reels after they come off the system, one of the issues that we've talked about in the past is labeling. You know, when reels come into factories, they've got so many different labels applied to them and barcodes and things like that, it gets confusing. If there was some sort of standardized system where one barcode was put on a reel and it carried throughout the life of the reel, it might simplify things a bit. So going back to you, Mark, what steps can we take to really optimize and improve supply chain logistics with the suppliers?
Well, I mean, you pointed out labeling just then, Trevor. We see this a lot where we basically, we're having to supply labeling systems to customers to help them create what we call a unique ID. That is like a license plate, as it were, or unique ID that follows the reel through its whole life in a factory. And it contains all information on the vendor, the lot code, and the quantity as it is today. If there was some kind of standard for that in the industry, then that would make it a lot easier, because that's normally the first blocking point in implementing a material system in the factory.
Yeah, I agree. Michael, do you have a view on this?
Yeah, I agree. When we go, especially into the tier 3 and 4 vendors, that is the first thing you run into. We have material control systems, material control software. We can track the components as long as you can get this unique ID. And we offer different ways of doing that. I mean, there's different systems of counting and making sure the data is going right going in. But that's one of the things that we always run into is, especially if they haven't come into the system with knowing all the reels and their quantities, garbage in is garbage out. And so getting a reel and an ID on here, making sure it starts out right, and then maintaining that correct quantity through the entire process is actually the easier part than, in some cases, getting your whole factory set up with the unique IDs.
Right, okay. Franco.
Well, there is actually effort to provide a standard barcode label, especially in Europe. In German companies, they use two types of labels, material label and PDF label with 2D barcode. barcodes, and we implemented that in some of our German customers, but I haven't heard of anybody in US, any other US company using them. So there is an effort and there is a standard actually, but if it's not used by many companies, it's useless. I want to talk a little bit broader about Industry 4.0 and supply chain. And in my paper that you didn't agree with, that part is that I advocate that ERP system be abolished and not be used. And the supply is actually provided by suppliers on site. And Industry 4.0 system should monitor the level of materials and the level of supplies in the plant and order just in time to finish, to complete the production, because in Industry 4.0, the goal is one-piece production. So if you want to achieve one-piece production, you have to be able to change over very quickly. And you don't have time to rely on your suppliers to deliver that on time. You will have to have your supplier on site, and you will deliver signals to them when to supply based on actually what's going on the floor.
Well, I would even go further than that. I think you need to have more visibility into your suppliers as well. I mean, if you look at, in fact, the best example in the world of a company that's implemented 4.0 successfully, I think, is the Siemens factory in just outside Nuremberg. And what they did was they narrowed down all their suppliers to the smallest group that they could manage with, and made sure that they all agreed to sign up to using the same software system, so that they could get visibility of the parts on the way to the factory, so that if they had a peak in demand or something like that, they knew if they could cope with it, or how long they were going to have to wait for it, or where the bottlenecks were coming from before they got there. I really think it's important you don't just manage the materials within the factory, you've got to manage it beyond the factory. Mitch?
And in some cases, actually, the factory and the supplier are under the same roof. We have many customers now who are working with their component distributors to set up on-site stock. So technically, the materials aren't owned by the manufacturer until they've pulled them out of the distributor's stock room, which is a caged area off to the floor. Yeah. So again, visibility and identifying and tracking the materials enables a much more lean and efficient supply chain, because you can actually be paying for your materials based on actual point of consumption. Going back to the unique ID topic, I think that's critical. We've been talking a lot about material counting, but there's other advantages to the unique ID. One is, for traceability purposes, you would have traceability of a particular container rather than a lot code in general. A vendor's lot code will have many, many reels that are all the same, and the labels you receive from the vendor would be identical. By adding a unique ID, we can differentiate between each reel from a lot code. So in the case of time-sensitive materials like moisture-sensitive devices, it's very important to track them as a unique entity, because you could have 10 reels from the same vendor lot code in your dry cabinet. The minute you take one out, the history of exposure time for that one item is different, so it has to be tracked differently. So that's another powerful advantage of unique ID. If later on you have an MSD problem, we can track down which exact reel was used and where that reel was used, as opposed to having to do a larger than necessary recall for the whole lot number. Last point on the labeling issue that I'd like to make is that we all want to have a scan-free system and a hands-free automated system with Industry 4.0, and we should think about RFID. RFID is an emerging technology. It's very easy to include a unique ID and all the other data that you need to track and trace materials on your factory floor. And our vision for the future is that, and our hope is that the component vendors will work with their large customers to start using RFID on reels, because that would facilitate a lot more automation.
It can certainly accommodate a lot more information as well. To Ranko's point, there is apparently an existing standard out there, but until customers start specifying that into their requirement, people won't really start using it. People are resistant to change. They're usually pushed by their customers to implement change. Let's move on to the next question, which is, how should a manufacturer measure or audit their existing processes. Anybody, any ideas on that?
Well, there's a couple of ways, Trevor. You can basically look at your uptime, calculate your overall equipment efficiency. There's different ways you can calculate that, but really it starts with putting a metric in place and then looking to see what was the cause of that inefficiency. Was it a man, machine, material, method, or what category or bucket you throw it in? And then that's the lever you have to pull to make improvements in the factory.
Okay, that's a good point. Michael?
And you got to look at it bigger than just the specific line itself. I mean, you have to look at your entire process. I've been surprised at times where people think that the placement machines are the gate in the line and it ends up being ICT, or it ends up being somewhere else in the line that they had no idea was gating their whole line. So this is actually where I think the Industry 4.0 and getting data from the entire line and processing data from beginning to end allows you to highlight the areas where these specific things are coming in and causing problems. Because everyone just assumes, hey, the placement is going to be your gate, and they look at that and they'll optimize those machines, and all those will have no gate, and then the gate will be somewhere else in their process. So it's looking at that part of the process. Also, it's the material handling, and kind of going back to that, but how are you kitting your products? How are you doing changeover? What process are you using to get the material and keep the machines running? Way too often, it's not the efficiency while you're running the product that you should be worried about. It's the efficiency going between product to product. And what tools and what processes is the customer putting in place to reduce those downtimes is really the key, where I think the biggest bang for the buck is.
Yeah, and if you've got a high mix environment, then it's even more important.
Right.
Yeah. Franklin?
Well, when we visit customers, we hear we really have no idea how we are doing. We might pick up some data every Friday afternoon and look into the data and see how we've done, but we don't know how we are doing, and we are not able to identify problem on time to fix the problem. So for that, Industry 4.0 should bring real-time machine monitoring, real-time OEE calculation, and bottleneck identification. So they can, so the customer can in real time see how they're doing and address the problem in real time. So that's, I think, the most important part of Industry 4.0 is a self-correcting assembly line and real-time monitoring of performance.
Right, okay. Mitch?
Yeah, I'll just briefly add that, I mean, it comes down to the foundation of connectivity. You don't know what you don't know. So unless you're collecting data from every operation from one end of the factory to the other, you don't know where your problems are. Once you have that connectivity and you're harvesting the data and presenting it in a way that's meaningful to the operators, then now you can pinpoint in real time when issues are happening, and anytime you gain visibility of an issue faster, of course you can react faster and make improvements. So connectivity is so important in terms of being able to have a vendor-neutral approach to harvesting information from your test machines, from your operational machines, from your operators as well, and using that to figure out the Pareto chart of where your issues are so that you can focus on the biggest priorities.
Okay. Well, I think, you know, as far as connectivity is concerned, there's a number of different software systems that are in process at the moment, still under debate, but that will address that situation. You know, we've got Hermes, we've got CFX, we've got OML, and we've got other solutions out there too. But I think that will work itself through the system over the next year or so, I would guess, you know. And certainly that'll make things easier and give us more visibility into making these other decisions. With a view to that, I mean, what steps can manufacturers take to improve their process specifically and their first pass yield?
Well, Trevor, there's quite a few systems out there at the moment. One thing you mentioned was standards and communication, right? We have the Hermes standard about to be rolled out at Productronica. That is going to make it easier on a machine-to-machine communication. It should make it easier to transport data with a PCB down the line. And these are relatively simple pieces of information about what do I populate, what do I look at or not look at. If I've already read a barcode in one machine, can I not just transport that information down the line to the next one, so we're not all doing redundant tasks through the line? So if that standard works out, then that would be a potential efficiency gain for anyone who's running equipment that supports that. Through the standards of CFX, that's still in progress, but that's going to give you a more standardized connectivity to higher level software. And that's where you can get this big data and start making intelligent applications that look at data and start connecting the dots about, if I have one process that looks like this, how's it going to impact my next process? Can I predict if I have this result in process A, how's that going to translate to process B? And the connectivity, as Mitch said, is key so that we can get the basic information out. Then you can build these more intelligent applications on top of that to do process optimization, improve yield, all those type of good things.
Okay. Michael?
Part of process optimization is actually reacting real time to changes in your process, whether that be parts or boards or those stuff. And really what you want to get to is lights out manufacturing, where it's not an operator having to do it. So what you really want to get to is getting the machine data from an inspection machine to adjust the screen printer if it's out because the boards have changed, or getting the screen printer, the AOI to adjust the placement on a placement machine. And really what that is taking the data in and actually doing something with it real time. Because as was already stated here is, if you get a bunch of data like a historian and say, ooh, that run we did bad, our first pass yield was much lower than expected. Okay, well that run's over. Right. Are you good in being in a high mix environment? You may not see that run for another 3 weeks. Are you going to remember to make the changes next time that you wanted to make and you knew you should make now, right? So you really need to have a proactive system that's taking all this data real time and actually applying it to your current process, and not just collecting it to be used at some later date. And that will be the advantage of when we get to an Industry 4.0, get all the machines connected, is actually using the data, not just collecting it all, but actually using it real time. And we are getting there with real systems. We have systems that we're working with our third party to implement things just like that.
Do you think, the smaller companies that are doing high mix, it's going to be even more important for them to use this level of process control? They're going to get more benefit out of it. Admittedly, they're the ones that are going to be least able to afford it, probably, but they're probably the ones that are going to get more benefit out of it.
Right, because the reason these guys are going to get more benefit of it, they're the ones who are going to run something once a month. A high volume guy who runs for the next 6 months, well, he can look at today's results, make changes for tomorrow, and I'm running better, and then make more changes, and he'll have an optimized process, and then he'll run it for a few months. But the guy who runs one run, 20 boards, and will run that again in 6 months, he's not going to remember what I should have done on this process, right? And so you're right. It's the smaller guys who are going to take the biggest advantage of the use of the data that's being passed back when it's actually in the place to get true functionality.
Ranko, do you have a view?
Yes, I mentioned earlier self-correcting line, and I think there are two important developments in Industry 4.0, which is one is intelligent process control, and the other one is intelligent machine maintenance, predictive maintenance. Because if you don't optimize processes, or if machine is not running, then you are not doing very well. And that's where applications of artificial intelligence will do a good job, because we have data that we collect from sensors for machine vibration and pressure, and we can predict, we can develop. Actually, we advocate machine to be smart enough to monitor its own maintenance, when it will go down, and send alerts, and actually create a maintenance plan. But in addition, what Michael said is very important, not only to collect test data and process data, but also to be able to monitor trends and also react in advance before actually line goes down, and correct the problem that will cause the line to go down. So process control and machine maintenance very important.
I totally agree with you, but I also think with machine maintenance, it's very important to make sure that your maintenance scheduling is done more intelligently, so that it happens during changeovers or that time. You don't have an operator coming or an engineer coming onto the floor and saying, I've got to stop this machine because I've got to do some maintenance on it now, and the whole line grinds to a stop. That happens quite a lot. You've got to be more intelligent about how you schedule your maintenance too.
But in Industry 4.0, there won't be any scheduled maintenance. Machine will schedule its own maintenance when it figures out I need to be maintained now, based on the actual data collected,
Right.
on the state of the machine.
Okay. Mitch, do you have anything input on this?
Well, yeah, I think that the question was about how we can improve first pass yields for high mix manufacturers, and I mean, two key points to look at is the once we're collecting this data from each operation on the line, use it in real time. So it's very simple, and it's very easy to implement today if you want to have interlocking at the front of your line based on the yields coming out of the ICT or functional testers. So once you have connectivity and data collection, easily in real time you can prevent production from happening if we detect or someone detects a trend at the end of the line. It's a very simple concept, but it's a very practical application of Industry 4.0, where data from one operation is used to prevent a mistake happening upstream. That's the real-time benefit that people can gain today from implementing these types of tools. The second one would be the historical data, as Michael mentioned. Analytics is, of course, a term we hear in every industry, business intelligence. I mean, once we have data and we're collecting it, then we can crunch it and plan better for the next time we're building a product based on how we did the last time we built it. And to your point that you made, Trevor, high mix manufacturers, they can benefit more than anyone else from this, because the variety they're facing makes all of this more critical. You have to be able to remember what happened the last time you built a product in order to build it better the next time. Yeah.
Excellent. Well, some really interesting debate there, guys. We're starting to run out of time, unfortunately, because the show is actually coming to a close, not just our debate. So I want to thank you all for taking part today. Of course, we have Mark Ogden from ASM Assembly Systems. We have Michael Slinsky, I'll get it correct, from Panasonic. Ranko Vujicic from Optimal Electronics, and Mitch DeCare from Kojiscan. And by the nodding of heads, I know I've pronounced the names correctly. So thank you very much for joining us today, and thank you for joining us. And that brings us to the end of our debates here at SMTA I 2017.